Good evening, everyone. It's very exciting to have you all here in this beautiful place to talk about IOTA for an evening. And to start, since we most probably don't know each other well already, I will ask you to shake hands with your neighbors. Just say hi. My name is X, and now we are all set. Good evening. My name is Maxime Bouillon. I'm your organizer and host for tonight. And together with some amazing speakers that we will have during the night, we will make our best to provide you with an exciting evening. So without further ado, let me welcome Andreas Osowski. With some warm applause, please. Andreas will introduce you the Flash channel, and I think that's all I have to say, and I let you the ground.
Thank you.
Andreas.
So, hi everyone, first of all. I'm Andreas. I'm one of the IOTA core developers based out of Berlin. We've been working on IOTA for, well, the better part of a year by now. Anyway, let's get started. So first of all, it would be good to know who here has seen, well, who here has been to the last meetup? That's a good number. Nice. All right, so what I'll be doing tonight is I'll essentially be providing you with a quick overview of what's IOTA, what we're trying to, what we're trying to achieve. And once that's done, I'll be doing a deep dive into the whole Flash channels thing that we've released last month. And then hopefully give you enough inside knowledge of how these actually work so you can go on and explain that to someone else as well, and maybe even participate in our Flash hackathon. So let's get started. How did we end up here? What was exactly IOTA? How did this come to be? So back in 2013, 14, like the founders behind the IOTA project essentially realized, you know, this is traditional blockchains, Bitcoin, Ethereum, I just wasn't around back then, but whatever, isn't really gonna solve the challenges that the upcoming machine-to-machine economy will require. So we need something that's very lightweight. We need something that is able and that can be easily used by machines, and that also facilitates the whole Internet of Things storyline. So that's how IOTA came to be. IOTA is essentially the Tangle, which is what we call our directed acyclic graph, which encodes the whole transaction structure. And it's going a step beyond blockchain because it's essentially a blockchain without the blocks and the chains. What exactly does that mean? So this here is a quick, you know, one visualization of the Tangle, where you've got all these different nodes in there, and these can be either transactions or bundles. Let's just go with transactions for now. And each of them confirms 2 previous transactions. And thereby you have a very large amount of possible growth. And whoops, it's not a blockchain because there's not a sequential line of transactions, but there's lots and lots of growth. There's a white paper, which is currently in our 5th version or something like that, and we're continuously updating that as well. Now, our main features, as I said, we came from this thought, we want to enable machine-to-machine payments, we want to enable the machine-to-machine economy. So we've got 2 things going on. Of course, this is still a crypto thing, so we need something that has a very cryptographically secure and cryptographic integrity guaranteed as part of the system. And we also need something that enables machine-to-machine micropayments. How did we achieve this? Few things, I'll just run through them quickly. So first of all, there's no transaction fees. If you send someone $1 US send or 1 single IOTA token, that other person will receive that same IOTA token. That's possible because there's no miners. Then there's also, because of the whole structure, because we don't have these mining pools, if you look at Bitcoin at the moment, there's like 6 or 7 which control 70% or something like that of the complete hashing power. So you've got a certain amount of centralization. And with us, the more the network grows, the more participants you have on a network, the higher the whole and global and total scalability goes. And at the end of the day, there's also the whole thing about partitioning, like you can actually split our network into different small chunks. As long as you keep them in sync, you will be able to merge them at a later point in time, thereby allowing you to do transactions without even having any internet connectivity. Of course, we have to be honest, our whole approach is based on the fact that we need a large enough network to be self-sustainable in the decentralized consensus way. In the past, well, up to date, there have definitely been more than 15 billion US dollars transacted using IOTA tokens, which is pretty awesome for us because I think we only got listed a couple of months ago on Bitfinex, and since then this thing has taken off exponentially. But you know, I've told you how we ended up here, and my thing doesn't work. Okay, the laptop doesn't work. Harm? Oh, that's quite a bit too far. Lovely. All right. It's working. It just got hung up. So I wanted to tell you a bit about who are we. Like, it's not just me. I mean, I'm as I said, I only joined recently, but there's a lot of other stuff behind it. So first of all, IOTA is being run and developed by this IOTA Foundation, which is a registered non-profit organization based out of Berlin, Germany. So we went through all the legal hoops and everything, and it took us until November this year to get that registration finally pushed through. The IOTA Foundation is entirely funded by our own tokens. So there's hardly any or pretty much none fiat investment happening here at all. So we thrive and we depend on ourselves doing a good job, and hopefully, you know, not just the crypto community picking up on us, but also lots and lots of business partners who are doing real-world projects with us. And at the core of IOTA, there's a team of, well, about 9 people. I'm down there in bottom, and we are globally centralized. We currently have got about 24 developers and, goodness, a certain amount of researchers, 16, I believe. The number varies a bit every week. And we are also, you know, because we know that we can't do the full security on our own, we also contracted some cryptographers who are world-leading experts in the field of lightweight cryptography. And we've got offices not just in Berlin, where I'm based, but this presenter, but also in Tel Aviv, where we're getting more and more people on board, Oslo, Chicago, and quite a few other places around the world. If you're looking at a world map, we're probably centered around Europe, Tel Aviv, and Australia at the moment. So we think that permissionless ecosystems are the future. So, you know, let's use IOTA, let's empower everyone, because you shouldn't be dependent on others to do the stuff that you want to get done. So our vision, apart from, you know, machine-to-machine payments, why are we here? Why do we do this? Because at the end of the day, we will not just have, we will have a machine economy. And what does this mean? This means that, you know, we won't have the dumb decentralization of the past, where, you know, you had your no connectivity. These devices were just monolithic repositories of data, but there was no way to exchange data. Then what we've got at the moment, so to speak, is smart centralization. You've got your smart devices, which always talk to one central cloud, and thereby achieve some purpose. But, you know, if your remote control provider switches off their service, all of a sudden in a couple of months' time, then you're just screwed. And we're really thinking that this will change and go towards the way of smart decentralization, where you will have all these local clusters where decisions happen, where transactions happen, where logic happens. So everyone will be surrounded by their own little cloud. And well, you can build on top of IOTA already today, because let's face it, smart decentralization is a thing that will be here in a few years, but is not here yet. Some things that are, for example, the data marketplace, which Harm will go into more detail on in a bit. The whole Industry 4.0 aspect, which is already starting to kick off, where, you know, you have got machines on your factory floor which you control, well, which you need to control, but at the same time you also want to have some kind of audit log that gives you an overview of which commands were sent to the machine, and gives you this overview without any party that's potentially involved in the process being able to alter the whole system and provide you with inaccurate data. Other things, OTA updates. So, for example, you send an update to a device. You want that update. You want the device to persist an update log, to persist state changes. This is very relevant for regulatory cases where an insurance might not pay out for someone when this person hasn't updated the device to the latest version, or producers might be liable for things. Who knows? So we enable this audit trail facility, but on top of that, of course, there's also the whole stuff like, you can have devices where you can opt in for specific features for a limited amount of time by sending them funds in the form of IOTA tokens. However, now let's get down to what I'm supposed to be talking about this evening, which is IOTA Flash channels. What are Flash channels? Essentially, they're state channels the IOTA way. These work by where you have your group of parties that want to set up this Flash channel, so they decide to set up a multi-signature address. Then funds are sent into this channel, and they have to be confirmed by the network, so the channel has to be funded. And then you can do all of these lots of transactions off the Tangle. So without going the full round trip through the consensus algorithm all the time, by essentially each party signing individual transactions all the time, and at the end of the day, you close the channel. Easy enough. Now, I didn't say that, but on there it says you have to decide how many transactions should fit into a channel in the first place. So the way these Flash channels are built is essentially, after you've exchanged your multi-signature signatures, digests, so you can create a final multi-signature. You also then need to create a certain number of addresses, which is what the channel consists of. So, for example, this channel here, this can contain 16 transactions in total. 16 because you've got 16 leaves of this binary tree. And what's happening here, essentially, so for example, you've got Alice who wants to do a Flash channel with Bob. Now, they set up their multi-signature stuff. They generate 31 addresses. And they generate 31 addresses, and then they send a specific amount of tokens into the initial root address, which is address 1 right up there. Now, when they then suddenly start sending tokens to each other, or when they send tokens to a third party, what's happening here is essentially they start moving, and this is guaranteed by code. They start sending tokens to the next hop in the tree all the way down to the first leaf. And thereby, they can actually always redecide where they're going to send tokens without having to re-sign everything. And because each of these individual addresses up there is always governed by a multi-signature address, you have always got some kind of proof, or it's just a fact that no one can touch those addresses other than the group that decides to do the multi-signature wallet address, be that a fully M2M group or M2N, where you can only have 3 or 4 parties that are required to sign a specific transaction. Now, once you've then got these bundles, once you've then got these transactions, and then you always move to the next leaf until the Flash channel is done or whatsoever. What then happens, because none of this has seen any kind of proof of work happening, is you take the final bundle usually and attach that to the network. Once that happens, the Flash channel is closed. There might be some funds left in one of these higher level addresses. But in that case, you will need to figure out how to resolve this with your Flash channel partners at some later point in time. And yeah, that's how easy it is to send funds in and out of a Flash channel. We've got quite a few graphs on our blog post that illustrated this. I didn't want to bore you with them tonight, so I just picked one, which also, again, elaborates and elucidates how to make a single transaction. So essentially, we've got demos for this. There's Eva and Yannick. not Alice and Bob tonight. So the first one proposes a transaction, then that proposal is transmitted to the other party or all the other parties using some side channel, be that a web RTC connection, web sockets, Bluetooth, whatever you want to do. It's really up to you. Then the other party has to agree on it and also sign the proposed transaction. And because we're talking about multi-signatures, so no one holds all the keys to these addresses, you need to generate the complete signature in parts. So you always need to round trip between the different participants and need to do all of this in order. And once all participants then have agreed and accepted to do a transaction and signed, and the bundle and the transaction is fully signed, then you've completed this transaction in terms of Flash channel transactions. And after that, you continue doing this. You eventually close the channel. Someone might screw you over because if you're, for example, agreeing to pay on a per kilobyte level when we're talking about internet streams. So think of the scenario where you're on a plane. At the moment, if you're buying Wi-Fi for the full flight, you're probably paying around 24 euros. You might have shitty connectivity, so those 24 euros might be wasted. Who knows? So what Flash Channels offers you and enables you to do here is essentially you can have this contract set up between you and the provider where you just send funds 1 kilobyte at a time. And because you don't need to do the round trip, because you don't need to do proof of work, which is at the end of the day a certain computationally expensive process, you can use Flash channels instead. So I hope that you've got a better understanding of what Flash channels do. If you don't hesitate to ask later on or find me later on this evening. But I wanted to also tell you a bit about where else. Oh yes, sorry, there's a video. Video kann nicht worden geladen. Yes. All right, there we go. So I wanted to show you this video of this happening in action. There's a demo which you currently have to download yourself because that deployment is broken, but we'll fix it tonight. So what's happening in this video is, you've got your two parties. You've got two different browser windows open, and they fund a Flash channel. This is all running on the testnet in real time at that point in time. And they start funding this channel, and this channel is funded with 2,000 tokens. So while they've got also this chat thing, they can just decide to move tokens to the other party, and the other party has to agree or to refuse a specific transaction. And this happens quite quickly. It's mostly just limited by the amount of time it takes you to do a signature. And then, eventually the whole channel is then closed. You do proof of work right in your browser using WebGL, and the transaction is sent off into the network, and it will be picked up, and then the value change will happen. And there's also some other demo that we did together with Satoshi Pay, where the idea behind it was to demonstrate that you can also have all of these lots of microtransactions happening for web page contents, where you fund a channel with a specific amount of tokens, then you click on an article, you pay for it, the server sees that you've signed a transaction, so it knows that even though the transaction hasn't been attached to the network, it can always do so itself, but it can also just release the content to you, because it owns the full signature. It owns a fully signed transaction for the specific transaction where you move tokens to the data provider. Huh? Right. So I also wanted to. All right. So at the end of this. At the end of talking about Flash channels, I wanted to talk about this competition that we're currently running called Flash Hack, which is a virtual hackathon which is running until the end of January, where we're dealing out a bit of prizes for users and for community members who are developing awesome solutions on top of Flash channels. There's a few prizes. This right here at the bottom is where you can find the Flash library. There's a dedicated channel to this on our IOTA Tangle Slack, where you can inquire and find teams, do whatever you want to. We're open for really anything here, and there's no categories to fit. So after Flash, where else are we going with this? So there's MAM, which you might have heard about, which Harm is going to talk about in a few. But of course, there's also other stuff. There's mystical stuff, which I'm not going to elucidate on tonight, which is key. There's the Trinity wallet, and I've heard earlier tonight that there's also Carrot Beer ICO tokens, wherever those are. Then there's the sole content idea of enabling private transactions on top of the Tangle just as well, which will be done via Tumblr. We've released a research white paper on this, and we're also in the process of implementing this further. However, oh yes, and there's also an ecosystem fund, because we've got tokens to spare, I guess. You should probably add a 0 to that, given our current valuation. But we're also still accepting projects here, so we want people to start developing on top of us, not just big companies, but we also want a community to form and people doing applications because they want to. However, for now, let's end with questions. I think I've got a few minutes.
Sorry, question will be a bit later.
Okay, questions will be later.
The evening, actually. We have a few more speakers, and we'll have a session of Q&A afterwards. So hold your questions, write them somewhere if you like. But thank you. First, Andreas. I hugely apologize for your lacks of internet. We will have a small break right now of, say, 10 minutes. So we come back here at 10 to 8. We have 2 bars open. One is downstairs and the other one is upstairs. So you can go to both and not overflow just one of them. And if you're online, take a break also. And we see you in 10 minutes.